profiles in a laterally insulated rod of length L with constant thermal conductivity under one-dimensional steady-state heat conduction and no internal heat generation. We'll determine which of the given temperature profiles are actually possible in such a scenario and explain physically why. Let's start with a diagram of the rod. We have a rod of length L with the x-axis along its length. The rod is laterally insulated, so heat only flows along the length from left to right. There is no internal heat generation. The key to solving this problem is the heat equation for steady-state conduction without internal heat generation. The equation is d squared T by dx squared equals 0. This tells us that the second derivative of temperature with respect to x is 0 everywhere along the rod. Let's write out the steps of solving this equation. Integrating once, dt by dx is a constant. Let's call that C1. Integrating again, t as a function of x is C1x plus C2. So, the general solution is a straight line. The temperature varies linearly with x, or is simply constant if C1 is 0. Physically, this makes sense. Because the rod is laterally insulated, heat can only move along the length. And since there is no internal heat generation, there is nothing inside the rod to curve or bend the temperature profile. So, the temperature distribution must be a straight line, either increasing, decreasing, or remaining constant, depending on the boundary conditions at each end. Let's look at the options. Option A shows a linear increase in temperature from left to right. This is possible. Option B shows a linear decrease in temperature from left to right. This is also possible. Option C shows a curved parabolic profile. This can only occur with internal heat generation or loss, but not here. Option D shows an oscillating temperature, which is impossible in steady state and with no internal generation. So only options A and B are physically possible solutions. Let's visualize these possibilities. So, to summarize, only a linear increase or a linear decrease, like options A or B, can occur in a rod with no internal heat generation at steady state. Curved or oscillating temperature profiles would require some form of internal heat generation or loss, which is not present here. This is a key result in understanding steady-state conduction and reflects the underlying mathematics and physics. So the answer is options A and B.